Alright, so we need to determine the magnitude and direction of the magnetic field at point P. Now this is a right triangle that I'm showing here, so let me determine this hypotenuse. We'll call this RA. Now RA is 0.48 squared plus 0.28 squared using Pythagorean theorem. So that's 0.556 meters. And this angle theta here, well, theta is inverse tangent of 0.28 over 0.48. Okay, and that works out to be 30.3 degrees. Alright, so let's figure out the direction of these magnetic fields first. So for the magnetic field due to wire B, the right-hand rule tells us that that curls around it like this. Okay, so if I draw a line that connects these two, the magnetic field has to be perpendicular to that line like that. So there's the magnetic field due to wire B. It points in the minus x direction. Right? And the magnetic field due to A, that's going to go around like this. Yeah? It's going to go around A like that. So if I draw a line from IA here over to point P here, I've got to go perpendicular to that. Right? So this has to be a right angle here. Now, if I continue on like this, and I continue this line, that's 30.3 degrees. And that's a right angle. So that means that this angle is 59.7 degrees. Or you could say that this angle is 30.3 and this angle is 90. That goes all the way around here. Alright, and those three angles have to add up. This angle plus this angle plus this angle have to add up to 180 degrees. So however you want to slice it. The magnetic field due to wire A points 59.7 degrees below plus x. So there's our two vectors we've got to add up. The rest of this problem is just really simple chapter 3 adding vectors together. So let's start by determining the magnitude of each of them. So the magnitude of the magnetic field due to wire A is 4.32 microtesla and is directed 59.7 below plus x. And the magnitude of the magnetic field due to wire B is u0 times 2.3 over 2 pi times 0.28. And so that's 1.64 microtesla in the minus x direction. Okay, so now we got to add up the x and y components. So the x component of the magnetic field due to wire A is 4.32 cosine 59.7, which is 2.18 microtesla. And the x component of the magnetic field due to wire B is minus 1.64. The y component of the magnetic field due to wire A is minus 4.32 sine 59.7, which is minus 3.73. And the y component of the magnetic field due to wire B is 0, because the magnetic field due to wire B points in the minus x direction. So if I add these up, this is plus 0.54, and this is minus 3.73. So there's the components of my final vector. Alright, so if I draw myself a little Cartesian coordinate system, I got to go 0.54 to the right, and I got to go 3.73 down to get my final vector. That's my total magnetic field. Okay? And the magnitude of that total magnetic field I get from the Pythagorean theorem. That's 3.8 microtesla. And the direction, I'll call this angle alpha, is the inverse tangent of 3.73 over 0.54, which is 82 degrees below the plus x direction. So there's my answer.